In this lesson, we are going to review linear and absolute value equations. Let's recall what's a linear equation. A linear equation, or a first-degree equation, is any equation of the type ax plus b equals 0. So any equation that can be written in that form is called linear. So we have x in the first degree and maybe some constant. We'll consider only equations with the coefficients a and b being real. Solutions or roots of such equation are the values of the variable that will satisfy the equation. So if I can replace x by certain value such that this equation will be true, then this particular value will be called a solution or a root of this equation. Solution set is a set of all possible solutions. So if we don't have any solution, the solution set would be an empty set. If we have one solution, the solution set will be composed of this particular one. But we can sometimes have more solutions. Here we have three examples of linear equations. And let's look at the solution set for each equation. If we want to solve the first equation, we'll want to bring the negative 7 to the other side to make it positive. So 3 plus 7 will be 10. Therefore, we have 2x equals 10. And then we want to divide the whole equation by 2. So x will become 5. Therefore, if x is 5, and if we replace x in the original equation by 5, then the resulting equation will be true. Obviously, 10 minus 7, yes, it gives us 3. So the equation is true. That means that the particular value 5 satisfies the original equation. Any other value than 5 will not satisfy this equation. We can say that this equation is true under the condition that x is 5. That's why such equations we'll call conditional equations, and in our case this equation has exactly one solution. Let's look at the following equation. If we try to solve it, we would like to, for example, bring the 5x to the other side, but then will be 5x minus 5x, so it's actually 0x, no x's. If we bring the negative 1 to the right, then we have 4 plus 1, which is 5. 0x really means 0, so we end up with equation that is never true, because 0 is never equal to 5. So this is never true. Which means that there is no such value for x that will make it true. Such equation will be called contradiction. There is no x value that will possibly make this equation true. It's always false. And therefore such equation has no solution. The solution set would be an empty set. The last equation looks really simple here, but what does this mean? Well, 1 equals 1 is always true. That means that no matter what the x value is, x can be anything and this equation will still be true. So, x can be any real number and it will still satisfy the equation because the equation doesn't depend on x at all. Such equation will be called identity. Identity has infinitely many solutions, so the solution set in this case is equal all real numbers. Let's look back at our examples. The first example was conditional equation, and in our case the solution set was composed of just one number, particularly 5. In the second example we had a contradiction, so the solution set was an empty set, and in the third example we had identity, solution set, all real numbers. When we solve equations, we are using the concept of equivalent equations. Those are equations that will produce the same solution sets. How can we produce equivalent equations? Equivalent equations can be obtained by adding to both sides of the equation the same value, or multiplying both sides of the equation by the same non-zero value. Here I am referring to just adding, in opposed to adding and subtracting, because subtraction can be considered as addition of an opposite sign number. Similarly here, I don't mention division because division can be seen as a multiplication by a reciprocal. Let's see how we will solve the following equations. In the first example, we would like to open all the brackets starting from the inner ones. So if we see a minus before a bracket, to open it, we have to reverse signs inside the bracket. So that becomes -3 plus x, copy the rest, copy the bracket, times 4 equals, deliver this minus inside the bracket, so it's -2, -7x. Before you open the next bracket, please collect like terms first to make this expression smaller. So 2x plus x is 3x, 5 minus 3 plus 2, everything times 4 equals -2 minus 7x. One more step, open this bracket, so multiply through 12x plus 8 equals -2, -7x. Finally, put all the terms with x to one side, to the left for example, so it's 12x. I bring the -7x to the other side. Formally, I am adding 7x to both sides. So this is plus 7x equals -2, and bring the 8 to the other side. Formally, I am subtracting 8 from both sides. Now collect like terms. We have 19x on the left and -10 on the right. Last operation will be to divide by leading coefficient 19, and we have x equals -10 over 19 as a final answer. Let's look at the second example. Here we have some fractions. Since we don't like to work with fractions, it's a good idea to multiply the whole equation by LCD of 6 and 8. So let's multiply everything by 24. That would mean that every single term, this is one term, that's second term, that's third term, has to be multiplied by 24. So 24 times everything what's here, 24 times 3, and 24 times everything what's there. When you have a product of couple factors, you multiply this whole term just once by 24. So, since 24 will be reduced with 8, leaving us with 3, the multiplication by 24 is already performed and we don't have it anymore. So don't try to multiply this bracket by 24. It is already taken care of by multiplying 1/8. So don't multiply twice. You multiply only once each term. However, this 3 needs to be multiplied and it becomes 72. In the next term, we'll simplify 24 with 6, leaving it with 4, and then multiply 4 times 5, which is 20. So 20 times the bracket 5 minus 3x. After the first step, there is no more problems with fractions, so we proceed the same way as in the previous case. Multiply through brackets 6x minus 3 plus 72 equals 100 minus 60x. Put all the x's to one side, so when you bring the 60 to the other side will be plus 60 together with 6 is 66x. And then it's 100 minus 72 and plus 3. That becomes 31. So we have 66x equals 31. Divide the equation by the leading coefficient 66, so we have x equals 31 over 66. So any linear equation can be solved that way. First, clear all the fractions by multiplying by LCD, then open all the brackets from inside out, like in the first example, then put all the x's to one side and the three numbers to the other side, and finally divide by the leading coefficient. Now, how do we deal with absolute value equations? Remember that absolute value really represents a distance from 0. So the distance from 0 is always positive. It doesn't matter which way, to the right or to the left of 0, but we go the positive number of steps. Which means that if I have equation absolute value of x, some unknown number, equals 2, then my number can be positioned 2 steps from 0, which really means it's either 2 or negative 2. So we have two solutions, 2 or negative 2. Generally, if we have any expression under absolute value and it is equal to some constant number k, we need to rewrite this absolute value equation by dropping absolute value sign, but there is a consequence. If you drop absolute value sign, then you end up with two cases. Your expression is either equal to the k or it's equal to negative k. As soon as you have these two equations, it's easy to solve them. So the rest of it is just to solve them, and you will end up with two possible answers. Your unknown x could be equal to p or some other number q. They don't have to be opposite. There are some numbers, it depends what kind of expression that we start with. So your final answer will be composed of 2 points, 2 numbers on the number line. So after solving absolute value equation like that, you may expect the solution set to be composed of 2 particular numbers. Let's try some examples. The first example, we have absolute value of something equals 14. So we rewrite this equation in 2 cases. Either the expression 3x plus 2 is equal to 14, or, and please write this word or, your expression 3x plus 2 is equal to negative 14, because your expression under the absolute value could be positive or negative. So please don't switch the sign of the expression, just write either 14 or negative 14. Then we are solving each case separately. So this is 3x equals 14 minus 2 is 12, divide by 3, and you end up with 4, or 3x negative 14 minus 2 is negative 16, divide by 3, so we end up with negative 16 over 3. Second example, here we need to remember that we can split the absolute value equation into 2 equations, as on this diagram, only if we have isolated absolute value. So in our case, the absolute value is not isolated. What we need to do first is to bring the 1 and 2 to the other side. So remember to isolate absolute value first, before you start dropping absolute value sign. So we have 2 absolute value x equals 4. Divide by 2, you end up with absolute value of x is 2. And then it's time to split in 2 cases. X equals either 2 or negative 2. So remember to isolate absolute value first before you drop absolute value sign. That will protect you from making mistakes. Here we have a couple more examples. How do we solve example C? Again, by rewriting the absolute value equation in 2 cases. Either the expression under the absolute value 3x plus 2 over 3 is equal to 5, or this expression could be negative, so it's negative 5. And then solve it. Multiply by 3, you have 3x plus 2 equals 15, or 3x plus 2 equals negative 15. Then subtract 2, so you have 3x equals 13, or 3x equals negative 17. And finally divide by 3, so it's 13 thirds, or x is negative 17 thirds. So we have 2 possible answers. The last example is quite interesting because what we see here is on the left hand side, this expression is always bigger equals 0. So it's always positive or 0. However, on the other side, we have expression negative 2 we have a number -2, which is always negative. Obviously, a positive number will never be equal to a negative number, so this is impossible to make it equal. Therefore, we don't really need to solve it at all. As soon as you notice that your absolute value is equal to a negative number, you can say that the solution set is an empty set, or you can say just simply no solution. Obviously, this needs some justification, so you need to show that you've been thinking about the different signs, that a positive is never equal to negative. What if someone didn't actually notice this problem with negative sign on the right and is trying to solve this equation? If we want to solve it the regular way, you will have to rewrite this as 1 minus x n equal to this number, -2, or 1 minus x equals to negative that number, which is +2. Now, when you solve it, let's bring the x to the right and the -2 to the left. Your x would be 3, or your x would be 1 minus 2 -1. Check if that works. If I plug it in 3 to my original equation, I have 1 minus 3 equals -2. True or false? Well, this is the same as -2, but absolute value makes it 2. Obviously, 2 is not equal to -2, so this solution doesn't really work. If you check the second possibility, -1, you end up with similar problem. 1 minus -1 is +1 equals -2. The left side is actually 2 and the right side is -2. Again, this solution doesn't work. So after all this hard work, you will have to claim that the original equation has no solution. So it was beneficial to notice from the beginning that the left side is positive or 0 and the right side is negative, and claim that there is no solution at once. And here we have the last example, an application problem. A retailer determines the retail price of a coat by first computing 175% of the wholesale price of the coat and then adding a markup of $8. What is the wholesale price of a coat that has a retail price of $156.75? Well, the first thing that I would do is to read again the question and set up a variable for what the question asks. What is the wholesale price? So if we use a suggestive letter, we can say let W be the wholesale price. Then in terms of W, we can follow the process of thinking of the retailer. How did he build the retail price? Well, he took the 175% of the wholesale price. So we take 175% as 1.75 as a number. Of really indicates multiplication, wholesale price, which is W. And then what he did, he added a markup price of $8, so plus 8. After that, he obtained the retail price, which is this much. So it's equal 156.75. And we need to solve it for W, a linear equation, not too difficult to solve. So at first, let's subtract 8. That would give us 1.75 W equals 148.75. And then we divide by the leading coefficient 175, which gives us W equals 148.75 over 175. And using calculator, we end up with $85. So the wholesale price was $85, and we should give a formal answer. So we can say the wholesale price of a coat is $85. And that would be end of this lesson.